Hello, this video will be going over the groove assignment for your lathe. Sorry, just checking on my sound. So this is your first project that you'll be doing for App 7. So you're going to have a couple concepts in here. You're going to have your G70 / G71, and then also you're going to have what they call a G75 for doing the grooves. You got a number of grooves. You got 1, 2, 3, 4, 5 grooves that you're going to be doing. So first thing you want to look at is how the print's laid out. Now notice that Z0 is on this side. Typically your chuck is going to be over here. Okay, so you're going to want to look at the print in a way that you're going to be coming in from this side. Okay, so it's going to be rotating around. Let me see if I can't get that. There we go. So this is the way it's actually going to be in there with your in your lathe. With, like I said, your chuck over here, and you come in this way. So this is still going to be Z0. So you're going to be coming through there. Now your G71 and G70 is going to be really short, maybe 3 or 4 lines. What you do want to do is chamfer this edge. And now there is no call out on the print, but on the CNC equipment, anytime you can program in chamfers, that saves time later. It makes that part cheaper to manufacture and a better looking part also. So put a 50 thousandths chamfer in this case, and that'll give you a nice little edge there. But you want to program then your G71 and G70. So after you get your outside done, that leaves us with the grooves. I'll jump into our programming book. On page 108 was where it starts describing your grooving can cycles. So inside your can cycles, what you're going to need is you're going to need X, which is your finished diameter. Z is the other opposite end of your groove from where you started, and we'll explain that here in a little bit. And then I usually like using I, which is your pecking depth and the radius value. U is the same thing, but it's in diameter value. Then you need K is for the shift, that how far it's going to step over every time. And then we also need a feed rate. You do not need a tool shift amount returning to clearance plane. So you need those features inside most of your can cycles. The first example they show on page 109 is just going in one time and coming back out. It would be something that the diameter or the width of that groove isn't very critical. But most of the time what you're going to be using is multiple pass grooving can cycle. Notice here our example here is for a 1/4 inch wide groove tool. Our tools are 1/8 inch, 125. But keep that in mind when we're looking at this example that theirs is 1/4 inch. So you have the same pieces of information that we've always had. Now notice there's no G96. If you use a G96 in here, your tendency to get chatter. Okay, so you want to just pick an RPM, and now that's what this is going to be, your calculated RPMs with your rotation. Very typical what they do is they still come down to Z.1, then down to X, and then notice now here you have another Z move, and that's your start point. That's one end of that groove. Now, one thing you have to keep in mind is now on this print, let's see if I can figure out what this is going to be Z0. Okay. This edge here is going to be 0.5. And this up here is 1.5. Okay, but now notice that they started at Z negative 0.75, not Z negative 0.5. Remember, this is the point when we calibrate our tools on it, whether it be we're using a tool probe or if we're using the actual part, that's the corner we're programming. So if we would go to Z negative 0.5 and we came down, you're going to come like this, and you're going to scrap your part out because it's going to cut too much. Oops, sorry, hit the wrong button. Getting all goofed up here. There we go. So when we come over, we want to be up here with our tool. because this is the edge, and that's a quarter, that's the width of our tool off of this edge. Okay, so if we were using our 125, this value here would be Z negative 0.625. But for this example, the 1/4 inch tool, you're going to be at Z negative 0.75. X is your finished diameter. Okay, so that's 1.75. And then Z is the other end of that cycle, or the other end of the groove. I, it's going to peck 50 thousandths, break the chip, break the chip. And then K is a step over. If we're using a 0.125, our K would probably be 0.1, something less than 125. And then you need a feed rate. And a feed rate of 0.003 to 0.005 works just great. Okay. And then after that, if that's the only thing we're doing, just those simple lines at the end to return home. In our case, we're going to be wrapping into the new Z location, another G75, a new Z location. You're going to have 5 of those. Okay. Now the other thing that's required on our part, one thing with the groove tool, it's not perfectly square. Okay. Exaggerated, that groove tool looks something like this. Okay. So when we come down and we just do straight cut ends, you're going to end up with a little bit of a rough surface in here. Okay. So what we're going to do is we're going to clean those up and make them nice and clean surfaces. So inside your G75s, I want you to leave in all your X diameters. So for this groove here, it'd be 1.815, 1.885, and so forth. So you're going to leave 5 thousandths on each groove. And then when you're done with all your can cycles, you're going to come back in and just program this in to clean that up. And you're going to do that with G01s and G00s. Okay. Now the tools are not meant to cut in this direction, but if we only leave that 5 thousandths plus whatever that rough stock is, that'll cut it very nicely, and you'll get a nice smooth edge on that bottom, and it'll clean it up. So you're going to go G01, 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 G00, rapid, G01, G01. So your dimensions are all the same. The X's are going to be your finish instead of that plus 5 thousandths. Your Z's will be all the same. It's just important to keep track of your G01s and your G00s. So that kind of concludes this part. Good luck with it. If you have any questions, please come and see me.